This is a production of Cornell University.
There. So, my title today is A Time for Barley to Go Naked After 10,000 Years. And if there was a subtitle to this presentation, it would be The Conclusion of Another Man After a Life with Barley. And that is because I have spent the last 30 years, my professional life, working on barley. And there is a book, a real book out there, this is not Photoshop, called One Man's Life with Barley, and it is a much better book than anything I could write, and it's by Harry Harlan, and he was one of the pioneering plant explorers and traveled the world and was responsible for, I think, a lot of the vision that we have for conservation of plant genetics resources. And so if you have a chance to get a copy of One Man's Life with Barley, I'd encourage you to go there. Let me dissect the title a little bit here. It wasn't intended to be at all, sort of the kind of thing to bring people out after lunch. But first, let's just do barley. And what's barley? For those of you not familiar with it, it is Hordeum vulgar, subspecies vulgar. You will see it often referred to as just Hordeum vulgar, but technically we should use the subspecies because it is completely interfertile with its wild ancestor, which is subspecies spontaneum. It's a diploid, has a large genome size, has that sort of average number of genes, and it is a hermaphrodite. And so this is kind of all important in the breeding and genetics and so forth of this organism because it's highly tolerant of inbreeding. And as a consequence, we see primarily pure line varieties throughout the world. There have been kind of on and off attempts at hybrid production in barley, and those really haven't caught on until recently. Syngenta's been marketing some hybrid feed barleys in Europe with some considerable success. There is still public and private plant breeding in the Americas, and so my colleague Mark Sorrells and students on his project are still barley breeders and wheat breeders and so forth at universities. We have had a much greater presence of the private sector in cereals breeding in the last several years here in the Americas. In the rest of the world, really, then it's a private venture, and so barley and wheat have long since gone down the road that we've seen in the U.S. with corn and soybeans and other crops. So let me get to the naked part of the title here. And the naked in this case refers to the adherence of the lemma and palea to the caryopsis, to the seed. And so if they adhere, then you have what is called a covered barley. And if they don't adhere, they're non-adhering, you have what we'll call a naked barley. And I'm going to use this naked nomenclature after Takeda et al. Here, who are the ones who cloned this gene and then reported it in 2008. Because by saying naked and covered, you just get around this real messy kind of grammatical semantic thing. Because if you want to say that a barley doesn't have a hull, is it hull-less with a hyphen? Is it hull-less with just two L's? And it's complicated and further complicated by the fact that if that's hull-less, then what is the alternative? And it's hulled, which can be misconstrued to sound as though it has had its hull removed. So it's just easier to say covered and naked, I think. So hence the terms. The gene abbreviation is nude for nudum, and the covered form right here where we have the adhering lemma and palea is dominant, and it is indeed the wild and ancestral condition. And when Takeda and his group cloned this, they identified this as an ethylene response factor. It's a transcription factor, and the mechanism by which it works is that there is or is not the formation of a lipid layer between the lemma and palea and the pericarp. And if the lipid forms, then the lemma and palea sticks, and if the layer doesn't form, then it threshes clean. So for you folks who are familiar with wheat and other grains that thresh clean, this is like no surprise. It's sort of like, well, why not? You know, we thought all grains were that way. Barley is rather unique in being a major cereal crop, the fourth most important in the world, that actually has a tightly adhering hull. And so we'll kind of see some of the reasons why that has transpired. So now to the 10,000 year part of the title here. So barley originated, as did so many of our other crops and domesticated animals, in the Fertile Crescent, and then you saw a dispersal of barley from that ancestral site. And there's a couple of key traits that are part of that domestication syndrome, and the naked covered phenotype is one of them. So certainly shattering, or the brittle rachis, is characteristic of the subspecies spontaneum, and that's that condition, have a picture of it in the next slide here, that just facilitates seed dispersal. And so you definitely want the non-shattering, non-brittle rachis in vulgar, the domesticated sort. Spontaneum is a 2-row. For those of you not familiar with barleys, 2-row means you have a single row of kernels on either side of the spike, and so that's a fertile floret at every rachis node. And if you're a 6-row, then you have 3. So the ancestral form is 2, and the post-domestication form is 6. The spontaneum, the ancestral sort, has an adhering hull. I said that was a wild type, the dominant allele, and there are adhering and non-adhering hulls within vulgar. And in terms of growth habit, something we really won't get into today, but that is very near and dear to my heart, then you have just winter annuals in the Hordeum spontaneum, and then you have winter, facultative, and spring annual types present in the derived. So that, of course, gives us this kind of apparent situation, and we all know that appearances can be deceiving. That'll be my only political allusion today. But one of them is it seems that we have much greater diversity over here in vulgar than we do in the spontaneum. But in fact, of course, it's quite the reverse, because we had a number of evolutionary bottlenecks along the way where we've lost allelic diversity in vulgar. And so that is a very active area of research, is to go back and start to try to bring in or mine some of those alleles that may have been lost in the domestication process. This is a picture of the brittle rachis, and if you've never encountered this, you've probably encountered brittle rachis in other wild grassy weed species, and you walk through those fields in the summer and half the field winds up in your socks. And so it's an excellent seed dispersal mechanism, and of course just the thing we don't want in agriculture, because we want those seeds to hang on into their seeds to remain on the head as long as possible. What's kind of interesting about the BTR genes, and there's 2 of them, is that both of them are loss of functions. There's deletions, and that leads to a loss of function of the abscission layer there. VRS1, which is the 2-row, 6-row, is also a loss of function situation, also due, in this case, to multiple different deletions inside the same gene. Nude, the hull adherence, is also a loss of function. In this case, the whole gene is gone. Just Takeda and all revealed that in all the accessions that they looked at, the gene has just disappeared, 17 kb of it, plus some flanking sequence. They have then generated some new mutants, and then kept up with other ways of generating the same phenotype. Growth habits, again, not the topic of today's seminar, but loss of function deletions. And flowering time are also loss of function deletions. So there's just this kind of long list of these domestication traits being loss of function, and that kind of gives us something to think about. If you think about some of the simplest applications of genome editing, how many other things are there out there that you might want to go into and then just generate loss of function mutants with and come up with target phenotypes. So there was a paper that just came out recently here in Nature Genetics by Masher et al., and they report do a lot of nice genomics on some paleo botanical remains of barley at Masada in Israel, and there's a lot to see about this barley, including the fact that it looks very much like barley as we might see today. Inflorescence might be just a tad shorter, but one thing about it, it was still covered. And so 4,000 years post-domestication, in that end of the world, there was still covered barley. Now, Takeda et al. Argue that there was probably a monophyletic origin of the naked trait, and that domestication event happened about 8,000 years ago. So they're not sure exactly where this happened, but we've got a couple of hints as to where that may have been, and we'll come to that in just a second here. So you have this domestication moment, you have the Middle East, and then you have this just explosive dissemination of agriculture and animal husbandry across Europe and Asia, and that's proceeding at a rate of maybe about a mile per year. And so that may seem kind of slow if you can walk 20 miles in a day, but when you think about actually then planting, harvesting a crop, and then convincing your neighbor to plant and harvest that crop, then mile progressions every year are actually pretty impressive. So quickly, barley moves out across the landscape, and this migration and specialization then leads to things that come back to the hull. And so I've kind of told this little history here of barley, and then I'm coming into this sort of migration thing to tell you a little bit about Europe and a little bit about Asia, and then some alternate uses of barley and hulls in those two environments. So in Europe, you had an ever-increasing focus on barley for its use in the manufacture of beer. Not to say there weren't uses also for human food and animal feeding and so forth, but principally for beer, and principally the forms that were used were barley with hulls. And those tended to be spring growth habits, and they tended to be two rows. So in this little cartoon here, you see a representation of the Reinheitsgebot, and this is the German purity law. This is barley here, this is hops, this is water, and that's yeast. Of course, they didn't know about yeast at that time. That was sort of added later, but the argument was, and not the argument, the law was and is that the beer could only contain those 3 and 4 elements, and it did not contain adjuncts. So this is an angry wheat, an angry maize, and an angry rice up here who cannot participate in the beer as they are wont to do in American standard lagers. So when I first learned about this as a barley breeder, I thought, wow, that is just another example of people really knowing good beer. And so there's this German brewing tradition, and you'd think, wow, they had this law that just sort of embodied their knowledge about beer. And in fact, it turns out that it was probably, this law was there for a number of other reasons. One is it protected drinkers from high prices. It banned the use of wheat in beer so that more bread could be made. And so the fact of the matter was the beer drinkers were using up the available wheat, and that wasn't leaving enough food for the rest of society. And so they said, well, hey, make the beer out of the coarser grain and then leave the wheat out there for nutrition. Now, if you're a Hefeweizen enthusiast or something, you'll know that there was still a tradition of brewing with wheat in Germany. But the other piece there was that unscrupulous brewers were adding toxic and even hallucinogenic ingredients as preservatives or flavorings in their beers. And so, that's a whole frontier that will continuously be explored, I think, as we see an increase in craft brewing and legalized cannabis. And so those two elements will probably be coming together, and we may be promulgating a new Reinheitsgebot here to prevent that sort of thing from happening again. So meanwhile, a very different sort of scenario has unfolded in Asia, and particularly in Central and East Asia. There, barley assumes a role in food. And so its role in food was most notable in the Himalayan plateau. And so this gentleman's a Tibetan Buddhist monk, and he's preparing to eat some sampa, which is, in this case, prepared from a toasted barley flour, and that's mixed with yak butter and green tea. And so it's a very nutritious material that can be very easily prepared. They're at very high elevations, not a tremendous amount of infrastructure required to prepare this food. And so a recent paper in Science by Chen et al. Actually argues that barley, in fact, allowed for the settlement of the Himalayan plateau, that you simply could not have moved into those higher elevations had it not been for this very early maturing cereal, and also, in their case, a cereal that was naked so that it could be immediately consumed. So you may ask, well, why can't you just eat barley? So you could, but that lemma, the lemma and palea, that hull consists of cellulose, hemicellulose, and lignin, and it's not palatable. It is insoluble dietary fiber. And whereas a lot of us need fiber in our diets, we generally don't need insoluble dietary fiber. And so it's just much easier to not have it there. Anybody eat barley today? Yes. Today? I mean, like, you ought to be eating it every day, Jean-Luc, okay? So we'll talk about that later. But, okay, anybody eat barley this week? Oh my God, that's why we come out from the west to the east and we proselytize our crops. Yeah, okay. So was it a pearl barley, perhaps, that you had, if anybody eats it? So what is pearl barley? Pearl barley is barley that has been mechanically abraded to remove the hull. And so if you have a naked barley, you don't have to pearl it. But pearling is this grinding process, and that grinding process removes the lemma and palea, and it also removes a little bit of testa, a little bit of pericarp, a little bit of aleuron, and that's enough to make your barley no longer be considered a whole grain legally. So whether or not you're losing, phytonutrients, that's a whole other topic of discussion here, but legally you cannot call that a whole grain. So not that the Tibetans were worried about whole grain or not, but they selected for naked, and incidentally, populations where there is high consumption of barley have the lowest incidence of colorectal cancers of any societies. So soluble dietary fiber is a good thing. Also has a number of other positive effects that I'll come to in just a little bit. This is just a quick walkthrough of a Japanese grocery store showing a whole sample of barley products that are readily accessible. Now, as you got into China and Japan and Korea, barley was an important part of the culinary nutrition culture, but of course rice was preeminent there. And so barley has kind of, to my understanding, a subsidiary role and sometimes a very sort of a negative perception role in those areas where it is viewed as the famine food. So it was what you ate only when you didn't have rice. And so that's been kind of a psychological barrier that people have been having to work through. So that kind of brings us to what's barley used for and what's and why. So what do we have here? Malt in the making. So the process of malting barley is a process of controlled germination. And this is the result of the end of the first phase and into the second phase. And so you've gone through what's called the steep, where the barley is alternatively soaked and then exposed to air, and then it's allowed to germinate, and these are the little rootlets that are emerging, and the incipient shoot is actually forming in under the hull, but you can't see it in this case because it is a barley that has a hull. And once that germination process is accomplished, then the barley is kilned, and depending on the temperature and duration of that kilning process, you come out with a range of malts, which then go into our beers. And so you have everything from pale malts all the way to roasted malts at the other extreme. So you might ask the question, well, why barley? Why don't we do this with anything else? And the answer is you can do it to anything else. And there are now malting companies that are malting other grains besides barley. Notable is one in Colorado called Grouse Malting. And their maltstress, Twila, is an expert in malting things like chia and buckwheat and other grains than for celiacs who would like to have malted grains going into a beer. But why malted barley for beer? So malted barley is like a perfect little nutrition capsule for yeast. And in the process of fermentation, what we're after is ethanol. And so we're harnessing the yeast to give us its excretia so that we can have ethanol and flavor. And if you wanted to design the perfect little nutrient capsule for yeast, it's going to be that malted barley kernel. So that's why of all the cereals that are out there, barley provides the optimum balance of starch, sugars, proteins, and that can carry on the fermentation process and allow yeast to do for us what we want it to do. So what about barley foods? So barley foods today account for a negligible portion of the total barley that's produced in the United States and consumed, certainly less than 10%. However, the FDA says that if you incorporate barley at a specified amount into your diet, you will reduce your risk of heart disease, you'll reduce your risk of type 2 diabetes, and you will achieve satiety. Achieving satiety alone is something that could be a goal for many of us, right? Just to sort of be cool and happy with wherever you are. So just eat your barley and that's where it will take you. So What accounts for this, these wonderful properties? It is a soluble dietary fiber fraction called beta-glucan. And beta-glucan is found in cell walls throughout the barley endosperm. Beta-glucan is found in appreciable quantities only in oatmeal. Otherwise, in oats, and in oatmeal, Mark Sorrells isn't here, so I can really knock oats. But in oats, it's only found in the outer layer of the endosperm, and that's why oats make that horrible, gluey, icky thing when you cook them, because the beta-glucan is just sort of right out there. You cook barley flakes, and you'll have actual integrity of each flake, but you'll still have the same level of beta-glucan. So as soon as the FDA comes out with this RDA, and there was research prior to that, then of course what do we do as plant breeders? Well, if a little bit is good, a lot would be better, right? So all of a sudden every breeding program is out there going, wow, let's breed for high beta-glucan. And so they've been in fact very successful in doing so. Your average barley, a malting barley, will contain about 4 to 5% grain beta-glucan. That beta-glucan in the malting barley is broken down by beta-glucanase, endogenous beta-glucanases during the malting process, and in fact brewers want low levels of beta-glucan in their beer, otherwise it becomes viscous and causes processing problems. So on the food, on the other hand, you say, wow, beta-glucan, I want this in my food, and so breeders have been very successful, even over the last 10 years, in developing high beta-glucan barleys, and they now have them up to, say, 15%. If you were to eat one bowl of barley flakes made from a barley that's 4% beta-glucan, that will satisfy your RDA. These are barley breads made with 40% barley flour. Barley has gluten in the sense that it will elicit a negative response in a celiac, but it does not have gluten for a baker in the sense that its dough does not have strength and elasticity. So your maximum blend is going to be about 40% barley going into a wheat blend. But if you have 2 slices of bread made with a barley that's about 4 to 5% beta-glucan, you will meet your RDA, a sandwich. So what happens if you eat 15% beta-glucan? Gastrointestinal distress of epic room-clearing proportions. So what then? Why do this? So plant breeders, be careful. Once you start going down this road of selecting for more, there are sometimes unanticipated pleiotropic effects, right? So what that has led to is kind of a schism in barley breeding, if you will, where if you have a whole grain model, you just can get by with 4 to 5% beta-glucan. You don't need that high stuff. If, however, you're on a model where you want to extract or fractionate the beta-glucan and put that onto a Twinkie or a Cheeto and call it health food, then you want to go for the high stuff. So there's sort of 2 different markets out there. So feed. 80% of the barley used in the world today is used to feed animals. Mostly ruminant animals, but I didn't have a nice picture of cows, so I had a picture of these pigs. And these pigs, in fact, are in a barley field. You see in the distance there, that is a barley field, and this farmer just unleashes them into barley fields and then moves the electric fence a couple of 100 feet every day, and the pigs are happier than if they were in clover. If you know the expression, like a pig in clover. So they're very happy. They're just eating this green barley as they go along, and that's the residue of the barley straw below. But most of the barley in the world today is fed to animals, and about 80%. And in the U.S., until about maybe 20 years ago, and we'll see the graph on this and talk about that in a sec, that was also the case here. Now we've had a complete flip so that almost all the barley grown in the United States is used for malting and brewing, a little bit for food and a very little bit for feed. But the feed markets are essential, in my opinion, because if you don't have a feed market, you have no safety net for your grain. Barley has excellent feeding properties, and a lot of research confirms that, and sort of brings us to this point here. So we'll talk about that research in a moment once we've talked about how we got to this. So what do you think this is? U.S. barley acreage, millions of acres. So if you follow this graph back to 1986, which is when I started my job, it's even more obviously linear. So it's a cause and effect relationship. The longer Pat breeds barley in Oregon, the more the barley acres in America go down. Long since established. God bless the tenure system, right? So there's a number of reasons why this has happened. Before we go into sort of this slope of despondency here, let's talk about this little plateau of encouragement over here and what that's due to. So that little plateau of encouragement is due to places like New York State, amongst others, where barley acreage is actually increasing. And why is it increasing? It's increasing because of the craft brewing, craft distilling, and craft malting industries. And then in addition, here you've legislated, and that has further driven barley acres. And so the craft industry is what is driving this slight increase. But it's really going to be a tapering phenomena because there's only so much barley that those industries can absorb. For example, if you're running a craft malting enterprise, 10-ton batch is a pretty respectable batch size. A lot of them are smaller than that. To run a 10-ton batch system requires about 500 acres of barley, high-yielding barley. So it doesn't take a whole lot to meet those needs. And so you have the Sunoco facility opening up here in New York State. That's going to have, I think, 6 10-tonners chomping on barley. And so that's going to lead to an increase in acres. But in terms of overall impact, it's still a couple of thousand acres will probably feed that machine. So what caused that decline? So there's a number of factors that contributed to that decline, but they are all feeding into this sort of story where we're headed here. And anybody in here ever played Pit? What was your favorite commodity? Just say barley. Okay, it's supposed to be the Chicago Board of Trade game, and so you're pretending that you're down in the pit and you're calling out commodities, and you got pork belly, and you got barley. Barley is one of the cards, but barley is no longer traded on the Chicago board. And so that sort of shows where it's at. Look at where barley is going here. The largest importer of barley, if you had any to sell, would be Saudi Arabia, followed by China. So China is a definite beer market there. Australia and Canada dominate that market. Saudi Arabia is primarily a traditional livestock use area, and a lot of racing camels are fed on barley. Not a particularly stable market, the racing camel, in an era of declining revenues in some of these countries. But what are we seeing? We're seeing a situation where barley is actually priced after corn. It's a function of corn prices. And so typically barley is priced at 80% of the price of corn. Corn prices now are incredibly depressed. If you follow commodities markets, their feed prices are incredibly low at the moment. If barley is 80% of something incredibly low, which is true, in conventional feed barley production, you lose money from the get-go. Okay? So that's a reason people don't want to have feed barley out there. Why are feed barley prices so low when the research confirms that probably the feeding value of barley can be the same or superior to corn in some feeding applications? A couple of things have happened which are so much bigger than anything that we can address as plant breeders or scientists that we just have to mention them and move on. So one of them are federal farm programs. We have a system of very indirect price supports in the US, and one of them is called revenue assurance, where you can essentially insure your crop, if you have the right crop, to a value that you know will allow you to generate a stable income. You can't do that for barley. Secondly, you have a situation where you've had changes in the confined animal feeding industry. So now you have enormous operations for consolidated dairies and feedlots. And even in Oregon, these folks find it cheaper to bring in Midwestern corn in unit trains than to buy barley from the farm next door. So that leads to a situation where you then have no market for feed, even if you did have a place to actually be selling it. And then you have kind of the final clincher in this, which is you have incredibly successful plant breeders in the Midwest breeding corn and soybeans. And corn and soybeans, along with global warming, have moved increasingly northward and westward and occupied what were barley acres in Minnesota and North Dakota. That corn and soybeans happens to be GMO, which is neither, here nor there, I think, in terms of that effect on barley, but it does play into the story that we're going to come to in a sec. Out in our neck of the woods, we don't have a whole lot of GMO corn or soybeans at this point, but we do have herbicide-resistant wheat. We have imidazoline-resistant wheat generated as a mutation, not as a GMO, but the consequence of that is that herbicide is applied to ground where formerly barley was a rotation crop. That herbicide persists for 12 months, and the barley can't follow in the rotation. So between all of those factors, then we've seen barley acres plummet. And what do you do? Well, since I've worked on barley for 30 years, I don't want to see it disappear. I don't want to see it just become a relic crop. But I do think that in addition to just wanting things to persist because they're cool, that there are reasons that barley can be advantageous. For farmers, it's early maturing, 2 weeks earlier than wheat, uses about 20% less nitrogen than wheat, but has all the same standard grain infrastructure. Processors, it's absolutely essential for malting. For food processors, the same infrastructure you use for milling, grinding, cracking. For the feed industry, rations and delivery can be the same. Consumers, gives you a range of beverages, heart-healthy foods, and some new sensory attributes in your diet. So I think there's a lot of good reasons to have barley out there in our lives. But it's hard to convince people sometimes that that's necessary. And so what I've got now is to shift gears a little bit, and I've kind of told you this barley story, and use you as a bit of a focus group because we're having a planning grant session at the end of this month. And it's funded by the NIFA OREI, so that's the organic research branch of NIFA. And a planning grant is where you kind of get people together to say, do we really want to write a full grant proposal on this thing? And the proposal is about the release, testing, and development of public sector multi-use naked barley varieties. So that's where I come back to this topic here. This is barley. Here, winter barley growing next to a GMO corn, and on a per unit efficiency basis, this thing is going to produce a whole lot more than this one over here. But in this particular case, this is not a comparison because that is a GMO corn, which this particular panel will not allow. So the question is then, okay, we come into the organic panel, what could we do that would capitalize on the kinds of research that they might be interested in funding, and why? So the first thing is that we're looking at market simplification here. So if you have a naked barley, in theory, it could be used for all three uses. Okay? You could malt with it, you could eat it, and you could use it as feed. So a farmer currently, if they raise malt barley, has barley with a hull. Can they sell it as food if they have excess protein? No, you'd have to grind the hull off. Can they sell it for feed? No, they're going to be at a loss. If you're growing a naked barley, can you get a maltster or brewer to use it? And the answer is no, because they're not familiar with malting and brewing with naked barleys. Can you get a feeder to use it? You're going to have to go uncover someone. So in the conventional large-scale commodity markets, there is not room to pursue this multi-use naked idea, hence the idea of saying, okay, the organic sector may be receptive to a newer idea, and thus that could be a platform where we could seek to get some acceptance, some adoption, and then let it diffuse out from there. Some attributes will be that it has to be naked, first and foremost. It has to have modest grain beta-glucan. You can't have 15%ers because the brewers won't use it. It's got to have normal starch. There's waxy and high amylose starch types. We want to avoid those. You're going to have yield and adaptation in your target environments, and you're going to want to have some interesting sensory attributes that make people want to eat this stuff. We can kind of follow a maxim that's been around there for a long time, which that a good malt barley is a good feed and a good feed barley. If you don't believe that, these are ice cream sandwiches made out of barley cookies with a barley malt ice cream. Sensory attributes, fiber, flavor, calories. Okay, so what are we saying here? That in this situation, we are looking for the elimination of the hull after 10,000 years. It's time to just go naked and then say, okay, let's focus on this particular aspect of barley. So why go, organic? Anybody in here done on-farm organic research? Organic breeding scale plots. Can be some challenges, right? Particularly weed control. amongst other things. And certainly in our environment, our university farm has a very limited certified organic acreage. They can't put in really representative rotations to properly encourage fertility and weed control. And so as a consequence, you get into this kind of weird input replacement and endless weed patrol. So this was an organic increase block of a new naked barley of ours. It's called Buck, okay? Buck naked barley. But there's some additional work there. We went the organic route again because the idea was, hey, there'd be perhaps receptiveness to this concept. We also struck out with the conventional panels. We had some really elegant genomic selection models for human food, and we created a resource I'll mention in a second here. But as I told the graduate students earlier today, never remain bitter about reviews, but just memorize them and repeat them, because someday that person's going to be in the room, and then they'll understand the mortal wound that they inflicted on a fellow scientist. So we got a review from one of these genomic selection proposals, and this individual says, you know, hey, I can hardly imagine barley as being the poster child for good nutrition. So it's like, get some fiber, dude, you know, but anyway. So what can we do to make this happen? So the first and fundamental thing, you may go, well, wait a second, barley has had a hull on it for 10,000 years because of the brewing tradition, and that hull is absolutely critical. So this is barley malting with a hull on it because of a process called lautering. And lautering is after you have taken your malt and you have boiled it and added your bittering hop, then that liquid called the wort is then passed through the grain bed in a process known as sparging and moved off to the fermenter. That grain, that spent malt at the bottom of that tank, then is a natural filtration system par excellence. And that's why hulls have persisted until today. So you ask the question, how can we get past that? And it is with a technology called mash filtration. Membranes and pressure use a whole lot less water and a whole lot less energy. So many breweries in Europe are already mash filter breweries. They went that way simply to reduce energy and water usage. In the US, Alaskan Amber, you may be familiar with, is a mash filter equipped brewery. And we've got 3 or so craft breweries in the US, including one that just built a new brewery in Bend, Oregon, Crux Fermentation Project, that is all mash filter based. So we do have ways now that you can move a naked barley malt, so this is naked barley malting down here, directly into a mash filtration system. For those of you that are barley people, one of the key parameters that we work on for malting is something called malt extract. Malt extract numbers of a good barley with a hull are typically around 80 to 83%. In a naked barley, that malt extract can be at 88 or 89%. What does that mean? That means more beer per unit of malt put into the brewery. So the brewers can be very attracted by that. What else is a hull bringing to beer? Astringency, microorganisms, things that you may not particularly want in some styles of beer. So I think that we have some advantages there for the brewer. What about for foods? So this was at a recent event in Portland called the Plant Variety Showcase. It's a thing called the Culinary Breeding Network. And so this is a local baker who's prepared a series of breads from different barley varieties, because the point of this was to showcase foods made from a range of barley varieties and pepper varieties and squash varieties and so forth. And so yes, you can do it. You can make delicious breads of all sorts and styles with different types of barley, up to about that 40% inclusion rate. And that could be exactly the same barley that went to your malt house could go into those loaves. And better yet, the malt that you made out of that naked barley can also feed back into your baking system. And that brings in a whole other palette of flavors, aromas, and sensories. Finally, the organic feed sector, at least by the advertisements we see, they all have a much better time at their lives than some people in some other sorts of operations. And so optimistically, yes, we can see whole grain barleys moving into various animal feeding regimes, because that safety net is absolutely essential as the third leg on a stool, if you will, for marketing a barley crop. So now we come to the plant breeding part of this, finally here in the last, 7 minutes or whatever that we have. And so, after 30 years of writing grant proposals to brewing companies and NSF panels and other people about different aspects of our crop. Finally, this is like the first time I get to write one that's just sort of carte blanche, and you go like all the way back to those just like sort of fundamental things about what you do with the breeding program. And one of them is, what are your target environments? Who are your target users out there? What are the target traits you're going to work on? What kind of germplasm are you going to use? How are you going to advance that germplasm? What is the basis of your selection? And what kind of varieties are you going to release? So I'm just going to kind of walk you through these real quickly and then open it up for some opportunities for discussion and perspective here. So the target environments that we have are the Pacific Northwest, the Upper Midwest, and the Northeast. That would be New York here with Mark Sorrells. And this is our colleague Kevin Smith in Minnesota. Why these regions? Well, we had plant breeders who are interested in this. We have processors who are perhaps early adopters of some technologies. We have consumers who are interested in a variety of foods. And then the anticipation is that we would see a subsequent diffusion out into other geographic areas and into the conventional sector as well. Our target audiences, here's one that we cannot neglect, I don't think, and this is a very good friend of the family's, and we had one of our food barley composites growing in her garden, and so she invites her friends over, and we have this sort of little harvest party. These people had never grown a cereal, they had never processed a cereal, they had never prepared a cereal that was 2 hours old, and so we harvested this barley, took over our threshing machine, harvested that, prepared it, and had a barley tabbouleh made from something they'd harvested hours before. We hit 10 people out there who went and told 10 other people who told 10 other people about how barley was something you could grow at home, and it was really cool, and it was good for you. And so there's an important piece there, but of equal and greater importance are their children. And so moving barley into schools and through various science and education pieces. And so we call those sort of the learners, and they're going to have very small acreage things. We have artisans, and these are the folks down at your farmers markets who may have in the tens of acres. Craft, maybe the hundreds of acres, and then the industrial sort of regional folks, maybe 1,000 acres, levels. And so there's different audiences we're going to be targeting here, and I think we need different kinds of germplasm for those people. And there's going to be different sorts of traits that we target. Everything has to be homozygous, recessive, nude. I think we just have to have naked barley. Malting and brewing quality is something that already exists. We have the American Malt Barley Association. It has guidelines. We need some allowance for higher malt extract. They're not going to complain about that, but maybe just a little bit higher beta-glucan, maybe a 200 instead of under 100 where they are now. I'm not talking scary levels of beta-glucan in beer. Food quality is really very simple as long as you don't bring in novel starch types or high beta-glucan. Our life as barley breeders could almost be as simple as that of corn breeders. You just breed for yield. You just want more of this good naked stuff growing per unit acre. Now, of course, you've got all the additional challenges of what's going to make yield under an organic system, but it's yield that you're after. And feed quality, I think it's yield. Ultimately, once you get greater market penetration, then you'll start to see, I think, some feedback into the breeding programs that says, we need that flavor attribute. We need this kind of kernel hardness. We need something else. But we don't have those signals now. Growth habit, I'd like to see facultative and spring barleys because of climate change, but winters are okay. 2 rows are preferred, but 6 rows are okay. Colors, a whole palette is okay. If you're breeding for conventional markets right now, you'll recognize that this is not the way that you can breed for large commodity producers. They'll tell you what color, what specific level, of 101 traits, and so you're much more confined and defined in your breeding scheme. The germplasm bases. We've got some ongoing naked barley programs, and we have something called the naked barley doubled haploid composite. We've got a germplasm release on this that we're writing up right now, so it'll come out, but the seed is available if anybody would like to get this. It's 900 double haploids derived from about 35 crosses amongst 28 parents, 40 different grandparents that we sourced from 14 different breeding programs and selections. We created this resource in anticipation of doing this genomic selection program. Grant didn't get funded. We're in a hurry, had to harvest. We said, the hell with it. Drove the combine perpendicular to all the plots. Took us an hour. So we just mixed everything together. And so they're all in there, and we've sent this material around to home gardeners, schools, public breeding programs, private breeding programs. Mark Sorrells, your colleague here, has started a naked barley program based on the naked barley double haploid composite. It's got springs, witters, facultatives, 2 rows, 6 rows, whites, blacks, browns, etc. So there's a whole range of material in there. Some very interesting things to do with schools in terms of natural selection versus implemented selection. Germplasm and advance, we've got this, all the double haploids that are in this composite. We still have them, we have the original and remnant seed, so we have all 900 of those. My breeding program is 100% double haploid based, so we're producing new double haploids from cycles with naked malt barleys that have come out of a Canadian program, and we'll pursue a collaborative development and testing of those, but segregating generations will be available to those who would want them at some point. The basis of selection for that composite, you can simply go real easy. Bob Allard published this beautiful paper in the late 70s about evolutionary plant breeding, and he showed that just by planting the same mixture year after year for his 30 years at UC Davis, he had the same rate of gain as his colleague Charlie Schaller, who was running a pedigree breeding program. And Charlie was a pretty good breeder. So natural selection, bulk breeding is not to be denied, but there's directed phenotypic selection, genotypic selection. There's a lot of enthusiasm. I would say this is probably a focus of genomic selection internationally. And so there are thoughts that we might implement something to some extent in a program like this. And who's the plant breeder, professional or participatory? This is a participatory program we have going on with 2 folks in Eastern Oregon. This is Seth and his dad, Brad, and they're working with us to develop a variety, in their case, of double haploid barley that will specifically feed into their estate malting system. So finally, let's come to germplasm release. What sorts of varieties will we be releasing here? So, I'll lay it all out here. I'm an open source person. I get really concerned about tight control over germplasm resources, and so I support at least the concept of the Open Seed Source Initiative, and we have the variety Full Pint, which then we released underneath the auspices of that organization. We've been using germplasm releases. We have a particularly stuffy tech transfer office at my university. You could quote me as saying that. I've called them worse sometimes. But when they won't let you release something as a variety, you can release it as a germplasm through the Journal of Plant Registrations. That gets the material out into the public domain and people can access it. The problem being that you can't sell classes of certified seed. Finally, we've made some headway, and except here, varieties. I had the weirdest thing. This whole trip has been weird. I couldn't get here yesterday, so I had this time frame thing in my travel, and then the spell check quit working in my PowerPoint, and I haven't found a way to renew that. But anyways, we've got public varieties with no PVP, so that gives you an option there. The revenue thing is an interesting one, because our office will argue, as many, that, hey, we need to mine our breeding programs. They need to become self-sustaining. If we're going to have public sector breeding, it needs to pay for itself. If we use the current seed royalty as we'd have, 1,000 acres is something that optimistically we would have in one of those target growing regions. That would generate you about $2,000 a year. The university would take 1/3 of that. If you took your 1,000 acres and convinced your growers that they self-assessed on the amount of grain produced, then you'd start seeing some serious money, or even some percentage thereof. So I think that if you want to see this kind of breeding generate a revenue, you're going to have to look for some other funding model other than what we currently have. So with all that, Barley World is where we try to keep in touch with the world. Please have a look at us. Thanks to the many people who have worked on the Barley crew, past and present, and brought to you by these various funding agencies who have all given us funding over the years without restriction, and all of our germplasm and data are in the public domain. If it is not in T3, it's only because we just haven't gotten around to posting it yet. Thank you very much.
Yeah. We're back. How are you? If the naked barley, is there a greater opportunity for disease susceptibility in those heads? Was that you?
Yeah, don't know, I guess would be the first question. So then you might, so the question was, are we going to get disease issues by going to naked barleys over barleys and holes? So we are not a fusarium head flipping area, World, so that is not something that is on our immediate horizon, but things are interesting. So we'll see. So I don't want to say, no, we're not going to worry about it. We have not seen disease issues. You do have to take extra care in threshing and processing that grain so that you don't damage the embryo, because that can reduce your germination rates. And you could ask the question, why was the Masada barley covered? Surely they had identified naked variants by that point, and they were probably making some beer, but they were probably also eating this. And so there may have been some advantages under those harsh environments for the persistence.
If you've got a mash filter setup, can that be used with covered barley, or is it basically, traditional setup works with covered and the mash filter setup works with naked?
Yeah, so question was mash filtration. They are being used widely today, in fact, all with covered barleys. So what it does is, instead of making a kind of a coarse grist out of your malt, you can essentially hammer mill that down to a fine powder, at which point then you're also getting more out of that mixture, and then that instead of having that fine powder having 10% hemicellulose, which isn't giving you anything, it would be 100% starch protein.
Another question concerning the relative malting of these different cereals. Now, barley has 3 layers, cell layers in the underworld, and maize, wheat, and so on, only one. Is that actually, does that translate into why barley is sort of historically the favorite cereal for this purpose? I mean, usually it's 3, sometimes it's 2, but does it have higher metabolite production than wheat, for instance, and so on?
Yeah, so question related to could the structure, the outer structure of the barley seed, particularly the alurone layers, have an effect on, or be responsible for the fact that it is the favorite cereal for barley? I would hazard that that's a good hypothesis and starting point, because it's not just the sheer level of enzyme. I'm sure that you can find an organism that would have a higher beta-glucanase or a higher beta-amylase or a higher alpha-amylase perhaps, but it's the balance of those across, plus the fact that you've got a lot of soluble carbohydrate that actually accounts for barley and its advantages. So we do know that gene expression in the alurone with signals from the embryo during germination accounts for a lot of the enzyme activity that is what we're capturing. But I can't answer your question if it's because barley has 3 layers or more. You can look that up.
Is there any effort to select barley with imidazolinol resistance, like wheat and sunflowers and other possible weeds have been selected for?
Yeah, so yes, and Steve Ulrich, who was the breeder at Washington State, now retired, started a mutation breeding program to target the same gene that then was mutated in order to give imidazoline-resistant wheat. His successor, Kevin Murphy, is carrying that work on, and they are in the process of releasing imidazoline-resistant barley. So the question, is that a plus or a minus in the systems, I think, the global kind of agrogeography? Clearly, that's a solution. Also, in Australia, they now have released commercial imidazoline-resistant barley. In the Northwest application, they would be so they could be put back into a wheat rotation without the use of those herbicides, particularly. They're not really needed in that configuration. In Australia, they needed an additional herbicide in order to deal with some of their weed problems. Unfortunately, I guess that class of herbicides is one to which weeds rapidly evolve resistance, so it's not a particularly sustainable long-term alternative for wheat.
So what are the difficulties that you try that you convince the farmer or the oil or conventional farmer to do the harvest?
So right now the challenge we have, so the question was, how do we convince a current grower of barley, covered barley, to go to hulless barley? First thing we have to do is assure them a market. And so, in fact, the first phase of this proposed project that we're putting together would be to produce large, semi-commercial amounts of grain so that those artisan and industrial users can access enough naked barley to make commercial malts, commercial beers, commercial foods, and get those out into the marketplace. It's not really, unfortunately, I don't think it's just a plant breeding problem. I think that the varieties exist. It's more of a marketing production issue to get that going. Yield-wise, there is not a penalty. So the top yielder in our breeding program, and we think we do a pretty good job the last 2 years, has been a naked barley. And so it was beating the best of our barleys with hulls, and the hull accounts for about 10% of the total mass of grain yield covered variety.
Yeah.
So how do you make a naked barley? Can you take a elite barley classical with the wool, and then how do you make it? Can you turn it into a naked plant?
Yeah, so naked barleys, how do you get a naked barley? So your simplest thing is going to be to backcross it in, however you want to accelerate that process. The genes on the long arm with chromosome 7H, and so it's not in some super heterochromatic region. There's no, that I know of, like other genes around it you have to be really careful of. So a pretty quick conversion program can work. We've done some of those kinds of projects ourselves, and that's how we got the naked gene into our germplasm, is through a marker-assisted backcrossing system. CRISPR, probably not going to be permitted by an organic panel. You don't know exactly where that sits. And indeed, it's not just this kind of real simple plug-and-play system, at least in barley, but this gene ought to be a pretty decent candidate because a couple of induced mutants have been identified that specifically do lead to a loss of function with a single SNP. So we ought to be able to manipulate that gene fairly readily. We've got a collaborative experiment ongoing just to see if we can do it.
Related to this question, so when you make a naked barley, you already went through a bottleneck, you said genetic bottleneck. When you do this back process, does it even reduce your genetic diversity further?
Yeah, so a problem. So in this naked double haploid composite that I mentioned that had 40 parents, 20 or so of those were naked barleys sourced from different breeding programs around the world. So at least with fingers crossed, then we have diversity at other positions in the genome, but according to Takeda and all, we are kind of monophyletic, and there was probably a single origin of that original mutation that led to the deletion of the gene. So there could be things right in the immediate vicinity of new that are going to be very important to us, and so that's where a couple of quick scans around around 7HL and other germplasm to see what important genes are hiding around in that neighborhood would be useful just to make sure we're not losing something.
There are no other questions. Please join me in reminder.
This has been a production of Cornell University, on the web at cornell.edu.